All right, huge lesson here in logarithms, properties of logarithms. I will tell you this, it might start off pretty easy, you'll understand it. Then as we go through, it's going to get a little confusing for you. Again, the video is just get the information, bring it to class, that's what we're going to learn. Don't feel like, oh my goodness, I don't understand this, I'm going to be in trouble. We will practice it in class, you'll get better at it tomorrow, or well, when you get back. All right, so here we go, properties of logarithms. In order to do properties of logarithms, we have to go back and dig back to exponents and think about our exponent laws, our exponent properties. So our product, we did this back when we first started exponents, and you should already know this coming in, right? When you have x to the a times x to the b, you have the same base, and you're multiplying with the exponents. What do you do with the exponents? We add the exponents. So this is going to equal x to the a plus b. We did do this, okay? You guys know that, right? X to the second plus x to the third. I mean, x to the second times x to the third is x to the fifth, all right? X squared times x to the third is x to the fifth. Just to give you an example of what we're talking about here, okay? So I'm just going to put in parentheses, add exponents. I'm writing sloppy here, okay? Add exponents. Now, how about when you divide, you subtract exponents. So a minus b, right? And that would be subtract exponents. Okay? And that doesn't look like a T. All right, and then when we raise to a power, we multiply the exponents. And what I want you to notice in all of these, a times b, what I want you to notice in all of these is the x just carries over. See how that carry over, the x just carries over. So the base is the x, and it really just carries over. We're going to do the same thing with logarithms. The base is going to carry right over. We're going to use these properties to write our log properties now. So remember, a logarithm is an exponent. We've talked about that a million times, right? So the product rule for logarithms, this is going to be extremely important, when you have the logarithm of two different bases, you're going to take the log of one of them, the log of a, let's say, and you're going to add the log of b. Because why? Because logarithms are exponents, so we add the exponents. This right here is an exponent, and this is an exponent, so we add the exponents. The base just comes along for the ride. So we're going to put the base x in there, but most of the ones we're going to do today are not even going to have a base. We're just going to do common logarithms to make it easy for now. But the bases don't really do anything with the properties. The bases just come along for the ride. They just carry over. How about log of a over b divided by b? So we're going to, just like we did for the quotient, we subtracted the exponents, so now we're going to subtract the logarithms. Log of a minus log of b. And then the x was the base, so the x just carries over. And this one's a little different. You don't take the log of both because it's the exponent of the a. So what you do with the b here is it goes in front of the log, and you say b, but you are still multiplying times log of a. And again, because it was the base of x, we just carry over the base of x. But we don't. It doesn't really do anything. So you, again, multiplying, we add the logs. Division, we subtract the logs. Raised to a power, we multiply the b times the log of a. All right? That's going to take a little getting used to. Now what we're going to do is do some examples where we apply these properties. In example 1a, we're just applying one property. See how it's 5 times x times y? Notice how I took the base out of these. See, there's no base, no base, no base, no base, no base, no base. That's just to, I don't want to add confusion today, okay? Tomorrow we review, we might throw some bases in there, but again, they just carry over. So log of 5xy. See how it's all together? Well, this is going to use the product rule because it's multiplication, 5 times x times y, just like AB, right? So we're going to write this as, and they want us to express it, expand it, and express in terms of log x, log y, and log z. So they want to express it like this, basically, in this form. So we're going to use the product rule. It's going to be log of 5 plus log of x plus log of y. And that's it. You're just using the properties to rewrite the expression. So the log of 5xy is the same thing as the log of 5 plus the log of x plus the log of y, and that's because logarithms are exponents, so we're adding the exponents. Got it? We're adding the exponents, we're adding the logarithms, we're adding the exponents. That's how it works. It's going to take a little getting used to. Once you get the hang of this, very easy. So now we're this right away in example B, we're combining the product rule and the quotient rule because I have a multiplication on top, but then I have a division. So that it's simple. We just say we'll do the top and bottom separately. So we're going to log of x. Everything gets its own log. Log of x. And because it's times y, we're going to say plus log y. Log of y, I mean. And then see how it's division? So we're going to say minus z. We got to say log z. So notice how in expanded form, everything gets its own log. Everything in the amount basically gets its own log. Okay, every base x, y, z, everything gets its own log. All right, here we go. This next one has multiplication, and it also has raising. Raise to the second, raise to the fifth. So that's the power rule. So now we're using the product rule with the power rule together. Okay? So we have log of 3 times, plus log of x squared plus log of y to the fifth. Okay, so that's just like what we did here basically, except you don't leave exponents in expanded form. We use the power rule. So what happens with the exponents? See how the b is up here, and then the b goes in front of the log? That's what you're going to do. You're going to take that 2 and put it in front of the log. So it's going to be log of 3, plus 2 log of x, plus 5 log of y. Okay, and that just takes some getting used to there. And that's going to be our final answer. These are going to be a little more involved. This one involves the product and the power rule. But this time, the 5xy is squared, the whole thing squared. So right away, we're going to do the power rule first and bring that 2 down in front of the log. We're going to do that first. Make it 2 log of 5xy. Okay, so that a 2, and we got to kind of put parentheses here because we're going to do 2 times all that basically. So it's 2 times the log of 5, just like number 1, or letter A rather. Log of 5 plus the log of x plus the log of y. But see how that 2 applies to the whole thing in the because it was in parentheses. So now it's going to be, we can distribute the 2 now and make it 2 log 5 plus 2 log of x plus 2 log of y. And you don't have to do that, but you'll see in these other examples where you're going to want to. All right. I know we kind of put these close together here. Try to squeeze this in the best you can. I'll switch colors. I don't want to see if I can move this over. Yeah, I'll move that off the screen a little bit for you. Okay. All right. So where are we at here? All right. So now we have this one here. The radical, remember, is raised to the 1/2. So I'm going to get rid of that radical and just say raised to the 1/2. That's exactly what the radical means. We did that in exponents, right? So this is going to be half log of x to the 7th, y to the 3rd. So it's going to be just like the one we just did. Half of log, it's going to be 7 log x, 7 log of x, plus 3 log of y. Okay? So 7, because it was, x to the 7th is 7 log x, that's the power rule. Now distribute the half. Half times 7 is 7 over 2. So it's 7 halves, 7 over 2, log x, log of x, plus half times 3 is 3 over 2, log y. And that would be the expanded form for that one. Okay? And then this last one here, again, the radical basically just means to the 1/2. So it's, again, half times, what's that? So it'll be 3 log x, 3 log x plus 2 log y minus log 10 plus log z. And again, this one's really tricky, so I don't expect you to get this. We have 2 distributing to do now. We got to distribute this minus because of the division. Subtract that minus, so we're going to have, that's going to be a minus, and then that half has to divide, that half has to go all the way through. So our final answer here is going to be 3 over 2, and I know you're not going to really understand this yet. Most of you won't. Some of you might. 3 halves log of x plus a half times 2 would be 1 log of y, and then half, so minus a half log 10, and then minus a half log z. And the last thing you could do here is that log 10 is 1. You should know because base 10, 10 raised to the what is 10? It is 1. So that's just a 1. All right, so that's going to be 3 halves log x plus log of y minus a half log z, and then minus a half would be the final answer there. And that, again, that's as crazy as it possibly could get. I'm just giving you that example to reference, but you probably won't have to do anything that crazy. All right, so now going backwards, just putting it back in the condensed form. It's called condensing. So now when you it's already expanded out. Now we're going backwards. Okay, so we're going to have the log of something. I have a subtraction, so I know there's a division. M plus n is m times n, and then say it's subtraction, that's divided by p. So anything before the subtraction is above the division sign, above the fraction bar, and then anything after that goes at the bottom. So you would have the log of mn over p. You don't have to put the dot. Log of mn over p. And then this one here, log, let's see what's going on here. So I have, again, a subtraction, so I'm going to put divide by. Anything before the subtraction, I have a base 3 here, so I'm just going to ignore the 3's. Just put base 3, log base 3, and we can kind of ignore the 3's so we don't get confused. They're there. I'm crossing them off just so we don't get confused. All right, so half q, this is q raised to the half. Q raised to the half. And then this is r plus, so it's r times. 2 log s would be s squared. Remember, that goes back to the exponent. So it'll be s squared, and then we're just going to make that log base 3. This is radical q over r times s squared. Okay, so that's pretty much, that's our properties, and we're gonna save the last few for our class time together. I just wanted to get you to exposure to the properties, and then we're gonna bring this in and do the last 3 examples in class tomorrow. We have a couple days to work on this lesson too. There's quite a bit. I know it looks like there's a lot, but they'll go pretty quick once you get going. We'll see you in class tomorrow.